Thank you all for attending this session. I am Rohan Vaikar. I will be covering this process simulated robotics portion in this webinar. There has been rapid development in the manufacturing space in the last decade. Customers must adopt measures to make sure their manufacturing systems are designed in keeping view of flexible production, global expansion, shop floor complexity, drive for quality, energy consumption, and constant improvement. Demand for robotics is growing rapidly to address market need to ultimately bring the product faster to the market. Process Simulate is an excellent platform to build the production digital twin of a manufacturing system. In the next couple of slides, I will be taking you through the capabilities of Process Simulate, which will help us evolve a plan in the mind to proper digital twin of a production line. This is the workflow of a building a twin. The first step is to gather the data required, that is machine and process element. Convert the 3D model into a dynamic kinematic model, followed by arranging all the equipment of the process based on the feasibility study. Manufacturing features are published and managed based on the process, followed by the path creation and OLP path. Let's take a detailed insight into first portion of that is modeling. Process Simulate allows us to model the kinematics of a geometry of a wide range of components. This is an example of sliders. As you can see in example, it have one cylinder which is having prismatic motion and point P1, P2, P3 having rotational joints. So that way we have to identify our mechanism and convert it into dynamic kinematic model. In this slide, you will see different mechanisms model in Process Simulate, flexible and complete modeling in Process Simulate helps the user to build the efficient digital twin. Let's move to the next topic, that is layout management. It is an essential to have easy platform for data transfer between different engineering applications. Process Simulate offers wide range of 2D and 3D modeling commands that helps the effective management of layout. In this slide, you see some of the examples of layout created and managed in Process Simulate for reference. Moving on to the next topic. Mainly, we will see two most common welding types used in automotive industry. The first one is spot welding. Spot welding is widely used joining technique in the automotive and its allied industries. Process Simulates offers a complete platform to author, manage, and analysis of resistance spot welding features. The process of spot import from external data source Excel is easy and direct. The different tools shown below help the user to import the spot data, assign them to the stack of parts, projecting them to the normal of welding surface, analysis of gun parameters, and finally arriving the optimal good design of a weld. The second one is arc welding. The arc welding is one of the many fusion welding processes used to join the metals. It is widely used in 2 and 3-wheeler automotive industry. Process Simulate offers a complete solution for arc welding features. Most continuous applications like arc welding, MIG welding, gap, and laser, etc. can be simulated with this feature. The different tools shown in the image help the user to create and project continuous manufacturing on a specific phases of a parts to which manufacturings are assigned. Also, with the tuning manufacturing data, we can create continuous manufacturing for them. Let us move to the next topic of the day, that is automatic path planner. When a large number of robots are employed in this process, the robot path creation becomes a cumbersome activity. To overcome the challenge, Process Simulate offers automatic path planning as an option which helps the user to create the optimized paths automatically. This command automatically calculates and creates an optimal collision-free path for weld operations, pick and place operation, and many more. While calculating the optimal path, the automatic path planner may add or delete the wire points. Moving further, we will discuss about part template. Robot program contains a vast amount of information of the process and location parameters. It is often necessary to configure the location parameters, for example, tool, speed, zone, etc., to define a path for a specific process such as spot welding, arc welding, and many more. Process Simulate enables you to define action in an XML template and apply the action to the multiple operations. You can set the parameters and OLP commands for the operation and for location. And also you can add approach and depart via location and set their coordinates. You can define many actions in XML template and apply them with a single click, saving repetitive manual configuration, increasing productivity, and reducing errors. Now let us see an example of XML template. In this example, you can see we have written a program for adding approach and depart location, which will be created at -10 in Z direction. Also, for this point, we have defined motion parameter as a PTP. In such a way, we can define most of the parameters for weld location as well. The next topic is robot cable. Robots are often equipped with external cables routed along the robot body. It is necessary to take cables into account when running the simulation to avoid damaging them. Process Simulate offers excellent tool to simulate the dynamic behavior of these cables. You can configure cable parameters so that simulated cable resembles and act like a cable on your shop floor robots. The simulation results help us to choose the right physical parameters of the cable and help the user to position the cable mount in an optimized position. The user can be sure of cable mounting on the shop floor and avoiding any surprises on the side. Moving on to the next topic, OLP. Working with different robots and offline programming with different robots. It is a simplified task in Process Simulator. You can choose the type of controller, set the RCS version, and choose to run the simulation in different motion modes before downloading the OLP program. Moving on to the next topic, robot safety. Robots are one of the most important components of any automatic manufacturing system. They are capable of performing various tasks reliably and quickly and posing a danger to people working in their vicinity. Often fences are used to keep the robots separate from workers and avoid any harm. Robot safety is a way to describe the surrounding environment to the robot so it can safely operate in it without causing any harm. In most of the robot systems today, safety is described to the robot via the definition of various geometry relative to the robot's own base, allowing the robot to make into consideration using mathematical calculations handled into the robot controller during prior or to the motion. Now, moving to the next topic, our expert Mr. Jitin will take you through the virtual commissioning part. Thank you.